Hello everyone. In the previous tutorial, we see how reinforcement is modeled in ABAQUS. In this video tutorial, we will do another example in order to familiarize ourselves with position constraints which are available in ABAQUS. This is our model. We will use a concrete block which is 200 by 650 mm and the width of concrete block is 300 mm. We will use a stirrup and there will be 5 rebar. Dia of rebar is 16 mm, so the area of each rebar is 201 mm square. Let's start. The concrete block will be a solid deformable body and 3D. Another part is rebar. It will be wire base feature. There are 5 rebars. Okay. Uh, let's Another part will be our stirrup. Okay. Now we'll declare material properties. There will be two material properties. One will be concrete, which will be assigned to concrete block, and steel, which will be assigned to rebar and stirrup. We'll declare two sections. One will be concrete section, which is solid homogeneous, and another will be rebar section, which will be beam category, truss type, and area is 201 mm square. Now we'll assign section assignments. Okay, done. In the previous tutorial, we see that in order to make the convenient in assembly module to assemble Rebar in the concrete block, we define some datum nodes. We will do it for the convenient of using Rebar in the exact location because there are some cover. So we will define some datum nodes. The exact operation will be done in this tutorial also. Now we'll go assembly module instance. There are several constraints which are available in ABAQUS. Let's have a look. It is said in ABAQUS manual that in general applying a single position constraint is not sufficient to define the precise location of the movable part instance. You must apply several position constraints, usually three for a three-dimensional assembly and two for a two-dimensional assembly to position a part instant in the desired or expected location. There are several position constraints which are parallel face, which are face to face, parallel edge, edge to edge, coaxial, coincident point. Okay, we are interested to use parallel edge. It is said that a parallel edge position constraint causes the selected edge of the movable part instance to become parallel with the selected edge of the fixed part instance. Okay, you see this these two edges become parallel, but the arrow direction is very important. It will become upward or downward depending upon which direction you have chosen. Okay, another is coincident point. Two part instances are attached together by a point which is coincident point position constraint. It is a coincident point constraint causes the selected point on the movable part instance to coincide with the selected point on the fixed part instance. Okay, these two are we are interested. There are if you are interested with other part instances, I would like to suggest you to go ABAQUS manual and thoroughly read these position constraints. I think it is mistake. You see that these are there to way. We want to assemble this river there. So I think the exact parallel edge, this, that one. Okay. Okay, that's good. Now constraint, coincident point. Oh, there's a mistake. Okay, let's do it again. Okay, you see this, that the rivers are assembled in the exact location we expect. Okay, stance river 2. Okay, do this exact operation you have done previously. Okay, okay, we have done or assembled the exact location. You see that these are my reinforcement and these are my stirrup. They are assembled in the exact location we expect. Okay, in the ABAQUS manual, it has been said that usually three position constraints are required to assemble a part in the desired location in case of three-dimensional assembly. But we see that in order to assemble stirrup in the exact location, we have performed two operations. So it sometimes it may take two operations. But usually, in order to assemble a three-dimensional part in the exact location, you have to use three position constraints. Okay, now steps. Okay, now we'll use a embedded region constraint. Embedded region. Okay, this is my embedded region. Host region. Okay, now we will apply boundary condition.